All right, hey AP Chemistry. So I wanted to make a quick question, just kind of like showing you from beginning to end how to do the electrolysis type of calculations. So in general, you're always going to have to be given or find out some current, there's some time, and then there's some identity of an element, and then you have some sort of reduction half reaction given or determined. So the question is, what mass of zinc will plate out if 55 amps of current are applied for 2 hours? And I drew like a little diagram, and I will get a video out to you about a diagram of how this works. But basically, if I have like a solution of zinc ions, if I electrolyze it with a current of charge, or if I get some electrons, right, I electrocute the solution, and the zinc ions pick up electrons and then plate out or become solid zinc, and they hang out on whatever electrode I'm collecting it from. Okay, so that is what electrolysis is and how that works. And I get a solid kind of plating out, and we're always trying to figure out the mass of them. So if I want to figure out what mass of zinc will plate out, there are a couple of things to keep in mind. I put two equations here. Q equals IT and Q equals NF. Q is the charge in coulombs. I need to figure out my charge. I is the flow of current. T is my time in seconds. N is my mole of electrons, and F is Faraday's constant, which is 96,485, which is how many coulombs there are in 1 mole of electrons. So here is the general flow. I need to go from time to charge. That's in general. I need to go from time to charge, and I'm going to do that through amps. And then I need to go from charge to moles of electrons, and I'm going to do that using Faraday's constant. All right, so this is going to be Q equals IT, this is Q equals NF. Right, I don't know if you could see that from here, you could zoom in, but I want to go from my time in seconds to my charge in coulombs, and I do that with Q equals IT. And then I want to go from my charge to how many moles of electrons are associated with that charge using Faraday's constant, or Q equals NF. And then if I figure out how many moles of electrons there are, I can figure out how many moles of my zinc or my element there are. And then once I get my moles of zinc, I can easily figure out my grams of zinc using the molar mass. All right, so something that's kind of new are these first 3 steps, but I do want to go back a moment. We talked about in class about the moles of electrons being related to the element. For this balanced chemical, or for this half reaction, I'm sorry, for this reduction half reaction, there are always 1 mole of zinc reacting with 2 moles of electrons. I have a new ratio now that I do need to include here. Okay, later on I'll need to talk about my relationship between my moles of electrons and my moles of my zinc metal. So let's start doing this. Let me do my first step. I want to go from my time in seconds to my charge. Well, I have 2 hours. If I want to figure out my time in seconds, 2 hours times 60 minutes in 1 hour times 60 seconds in 1 minute. Okay? Now, if I do this calculation, this is going to give me my time in seconds, and I need my time in seconds for these calculations. So I'll do 60 times 2, and I get 7,200 seconds. So I've applied this 55 amps of current for 7,200 seconds. If I want to go from time to charge now, which is my first thing, I could use this equation, Q equals IT. If I want to figure out my charge, if I take my time and multiply it times my current, 55, I will get my charge. So I could do Q equals IT, which I could do, I is 55 amperes, which is the same thing as saying a coulomb per second. An ampere is a coulomb per second, so my seconds can cancel out, times 7,200 seconds. So multiply that by 55, and I get 396,000. So 396,000 coulombs. Okay? So I could use Q equals IT to figure out how much charge. Okay? Or I could do dimensional analysis and multiply by 55 coulombs for 1 second, that's the same thing as saying my amp, and I get the same answer of 396,000 coulombs. Now there's another relationship that says if I have 1 mole of electrons, I will have 96,485 coulombs. I could use Q equals NF. Rearranging that, Q over F is going to be equal to N. So if I take this number and divide by Faraday's constant, 96,485 coulombs, this will give coulombs per moles of electron. This, and right now I'm over here, this will give me my moles of electrons. So I take this number divided by 96,485, I get 4.10 moles of electrons. Moles of electrons. Okay, so this is all of the tough stuff, getting to my moles of electrons. Okay, now if you were doing this the dimensional analysis way, like I said before, I could multiply my charge times 1 mole of electrons over 96,485 coulombs, and I will get the same answer of 4.1 moles of electrons. Now I'm not done here, because for every 1 mole of zinc, there are 2 moles of electrons. I need that relationship. I have more moles of electrons than I do zinc. So I'm going to take my 4.1 moles of electrons and multiply it times this mole ratio of 1 mole of zinc for every 2 moles of electrons. This is like dimensional analysis back to stoichiometry. So 1 mole of zinc for every 2 moles of electrons. Basically, I'm dividing that number by 2, and I get 2.05 moles of zinc that are going to be plating out. And then finally, the last thing that you should be able to do is go from moles to grams. I could just use the molar mass that's on the periodic table. Zinc is 65.38 grams. So if I multiply the moles times the molar mass of zinc, I will get how many grams played out. So 65.38, I get 134.2 grams of zinc plate out. Okay? So, that is how you do an electrolysis question with calculations. It looks like a lot. I've showed you every step. If you need to slow down the video or go back, let me know. If there's any part of this where you're really concerned, like where did you get this from? What are you doing in this step? Let me know. And if this was not helpful, if you have any other suggestions about how I could organize this question for you, let me know. All right, so use this video to help you with your calculations. You will have a question like this on a future quiz for Chapter 19, and the AP exam is definitely notorious for giving a question that's very similar to this. If you look at the question number 3 in your practice quiz, there's a question that doesn't ask you exactly this, but kind of goes backwards. So let me know if you have any other questions or concerns. Please make sure that this is something that you know how to do for Chapter 19.